Temperature. Temperature is a huge part to the body and the performance of an athlete. An event that takes place in extreme heat is the Des Sables Marathon, which is in a 40-degree heat. An example of where hot temperature has affected sport would be the Rio World Cup in football. They had to play most of the games in the evening and night as it wasn't as hot as it was during the day. Despite this, they still had to have water breaks halfway through each half due to it still being very hot and most of the players not being used to the climates. However, there are also events that take place in cold climates. For example, linking with the Des Sables Marathon, there is also a marathon that takes place in cold temperatures in the North Pole. This is where athletes from all over the world run in minus 30 degrees, and they would have to train differently beforehand so that they get used to climate change and are able to take part in the event. An effect on sports from cold weather could be outdoor events like football games are often cancelled in the winter due to a waterlogged pitch from rain or due to being too much snow on the pitch that the players aren't able to play. Cold. There are three different types of hypothermia: acute or immersion, exhaustion, and chronic. During acute hypothermia, you shiver due to your muscles contracting and releasing energy to warm up the body. Also, breathing rate slows down, and the participant can feel exhaustion and confusion, which leads to their speech being slurred or mumbled. During exertion, hypothermia, the participant tends to have a weak pulse and a slow breathing rate. Their speech is also slurred while feeling clumsy and drowsy. The participant can have a loss of consciousness and their skin tends to go bright red and their face and cold. With chronic hypothermia, the same happens to the body as the other two. The changes happen slowly over time instead of as soon as the participant gets cold. When an athlete is performing in a sport and they get colds, this can affect their performance massively. One being when the muscle is cold, then increases the chances of the muscle tearing, and this can lead to an injury. Despite there are also effects that can affect the athlete's performance, such as them fatiguing and not being able to put as much effort in for as long as they normally would be able to. It can also mean that they can get a poor coordination and disorientation. There's also a chance of cardiac arrest, but this is very unlikely. When the body gets cold, the hypothermia thermostat acknowledges the decrease in temperature. When this occurs, the peripheral thermoreceptors sends a message to the cerebral cortex in the medulla oblongata. The body then either has a voluntary or involuntary response. If the body has a voluntary response, this consists of putting more clothes on or rubbing their skin. But with an involuntary response, the body's response that occur are erection, where the hair on the arms stand up and trap the heat. In the heat, the body goes through different effects depending on the heat. At 38 degrees Celsius, the body starts to sweat. At 39 degrees, sweating increases and the heart rate increases. At 40, enzymes start to denature and dehydration starts to kick in. At 41 degrees, fainting can occur as well as vomiting and dizziness. When the body reaches 42, you can start to vomit and become more delirious. When the body comes to 43 degrees, you start to have brain damage and cardiorespiratory collapses. And finally, when you reach 44 degrees, you will die. To stop yourself from getting too hot, thermoregulation works to try and keep the body at the correct temperature. Some of these ways are hairs laying down to trap less heat, vasodilation of the blood capillaries, increased sweating, and a decrease in metabolic rate. All of this is controlled by the hypothalamus in the brain. These are involuntary responses. However, there are voluntary responses which are taking a layoff or having a drink. Hypothermia is elevated body temperature due to failed thermoregulation that occurs when the body produces or absorbs more heat than it can dissipate. Extreme temperature elevation then becomes a medical emergency requiring immediate treatment to prevent disability or death. As I mentioned about the Marathon des Sables, it is a 6-day, 251-kilometre ultramarathon, which is approximately the distance of 6 regular marathons. The longest single stage is 91 kilometres long. This multi-day race is held every year in the southern Morocco in the Sahara Desert. It has been called the toughest foot race on Earth. Over 120,000 litres are consumed over the event. Method. For the protocol, 10 minutes pre-cooling is done, which is controlled. 10 minutes of exercise in the chamber is also done. This is the same resistance that generated 135 beats per minute in Normoxia. The measures which are taken at rest are heart rate, RPE, TSS, ear and forehead. At the end of pre-cooling, heart rate, RPE, TSS, ear and forehead are also taken, and with exercise, heart rate, RPE, TSS, ear and forehead are taken as well. For rotation, the observer must stay outside the chamber when observing. There is a participant, a data collection, and a power management. In cycling, the cadence should be 70 reps per minute, and the pound weighs 1 kg, and there is an increased resistance by 0.1 kg in each stage. With the results, the red bar represents no pre-cooling, the purple bar represents an ice bath, and the blue one represents ice vests. In the first table, it shows the mean difference between no pre-cooling exercise of a heart rate and a pre-cooling ice bath heart rate. The mean difference is 54.38 with a p-value of 0.008. This p-value shows that it is significant as it is under 0.05. The mean difference for no pre-cooling exercise heart rate at heat versus pre-cooling ice vest heart rate shows a mean difference of 47.21 with a p-value of 0.000. However, this isn't under 0.005. There is a chance that it could be, as it only goes to 3 decimal places, as the number could be much smaller, so we don't know.